The theater's foundation is 32 meters deep. That's not only the deepest in Beijing, but in the whole country.
But only 18 meters, or 59 feet below Tiananmen Square, lies a layer of underground water. Excavating below it could buckle the ground under the hallowed buildings in Tiananmen Square, including the Great Hall of the People.
In order to dig that deep without disturbing the foundations of all buildings around Tiananmen Square, we had to both block and pump water while laying the foundation slab.
Workers run 28 pumps to siphon out more than 500,000 gallons of water every day. They install a concrete retaining wall to block water from entering the enormous excavation. After successfully laying the foundation, they seal the drainage wells and add a layer of crushed rock to help support the massive slab. Then they move on to the next challenge, erecting 148 arches inside China's biggest dome. A delicate task on a gargantuan scale. A 600-ton crane lifts the arches into position. But even it's not big enough to handle arches nearly 150 meters or 500 feet long. Workers must weld them together in 3 separate pieces. First, they erect a network of gigantic frames to give the arches temporary support. As the arches hang from the cranes, expert welders create seamless steel plates just inches wide, but strong enough to hold the enormous arches together.
After you've welded them together, the seam is as strong as anywhere else on the steel plate. It can take the same amount of stress. We call this a grade 1 weld.
Engineers test the welded seams with ultrasound. The slightest defect could have catastrophic consequences. Then, the ultimate test, removing the temporary arch supports. As soon as they're supporting themselves, the arches will drop. If they fall too far, the dome's shape will distort.
On paper, we calculated that the arches would sink up to 16 centimeters. So we deliberately built them 10 centimeters higher.
150 workers take positions around the dome. Slowly, they jack down the supports. The arches drop into their final position, and the dome drops with them.
In the end, it fell 12 centimeters, a difference of only 4 centimeters from our calculation. Just the length of the tip of my finger.
Believe it or not, the egg builder's next challenge is even more daunting. They have to install each of the dome's 20,000 panels by hand. And doing that will be even harder than it looks, because each panel matches only one other panel on the opposite side of the dome. So workers can't just install 20,000 panels. They have to place every one of those panels in exactly the right location. It's not a job for the weak or the timid. While balancing themselves on narrow rails along the edge of the dome, workers hoist every panel hand over hand to its exact position. And even when they've put all the panels in place, they'll face one more challenging task.
Each titanium panel is covered with a protective membrane.
Before the egg opens, dozens of workers must scramble over its dome, peeling the membrane off thousands of panels. revealing the shiny titanium beneath. Building the egg would be hard enough under ideal circumstances. But after the Paris airport tragedy, nervous officials closely monitor every aspect of the dome's construction, until investigators announced the terminal's design didn't cause its collapse.
The client issued a press message saying they were confident in me, that there was no reason for any stop, and there was not half an hour stop.
As the egg nears completion, Paul and Drew hopes that all of Beijing will embrace it, and that the controversy it's inspired will fade away.
Building an opera for an architect is an enormous chance. I don't think such a project could be made now in another part of the world. I mean, it requires a lot of hope, of pride, of vision of the future.
The success of the egg may have paved the way for some of Beijing's other daring Olympic projects. A radical idea for the new swim center gets a surprisingly positive response. And this fantastic structure is unlike anything else on Earth. At this massive construction site on Beijing's Olympic Green, crews are hard at work building the astonishing Bird's Nest Stadium. Beside it, other workers break ground on what will be the Olympic Swim Center. When it's finished, the swim center will be one of the few buildings in the world capable of sharing the Olympic spotlight with the Bird's Nest. Because it will be one of the most amazing structures ever built. An engineering triumph based on the mysterious magic of bubbles. Sydney, Australia, 2003. Arup Engineering's Tristram Carfrae searches for an original design for the Beijing Olympic Swim Center. He learns that two Irish physics professors have shown how bubbles can fill space with no gaps in between. And that gives him an idea.
The inspiration for the project, or the structural form, was considering how those structures form in nature. A sea coral, a sponge, soap bubbles. Only structural engineers do this, but it intrigued me. What would it look like?
Yeah, you can see that casting,
To find out, Carfrae takes his radical idea to Arup's team of computer wizards.
Right. Well, it just came to us with the idea that we'd build a building out of essentially bubbles. We just thought it was absolutely crazy and it would never get built. We just had to figure out, well, how are we going to take this concept and actually make a building out of it that's going to stand up? We had no idea. But then we started to develop it and we ended up with something that works.
Starting with a virtual cell based on a bubble, the team creates a molecule, then repeats it through space in 3 dimensions.
The building line was actually set in the middle of this array, and we basically just chopped out every side. Everything that was left was the structure that we were going to use.